Welcome. Here's some variation practice for you. I encourage you to read the question to yourself, pause the video, try to do the problem on your own, and then restart the video to see if you and I come up with the same things. Suppose h varies inversely as the 2/3 power of t. When h is 4, t is 27. Find a complete equation of variation to model the situation. Then use that model to predict t when h is 8. H varies inversely. It's important when you start a variation problem to figure out what kind of variation you have so that you know what your model needs to look like. The first variable that we run across in the statement is h, so we'll write that down first. H equals varies inversely means we will see a fraction format for this right-hand side of the equation, and that fraction format will have k in the numerator, our constant of variation that we don't know yet for this problem, divided by the 2/3 power of t, the second quantity that we come across. So that gets written as t to the 2/3. That's a generic equation of variation for this situation. That takes care of the entire first sentence. Then you're given a fact pair. When h equals 4, t is 27. You can substitute those features in, or those quantities in. H is 4. 4 equals k over 27 raised to the 2/3. 27 to the 2/3 is 9. It's the cubed root of 27, which is 3, and then 3 gets squared for 9. So our new equation, 4 equals k divided by 9. We need to solve this for k. We will multiply both sides of this equation by 9, so that 36 is our k value. That takes care of the information in the second sentence. The third sentence, find a complete equation of variation to model the situation. That means we need to take this k value and substitute it into our generic equation of variation, and that will be our specific complete equation of variation for this situation. Putting those two things together, h equals 36 divided by t to the 2/3. So that part, there's your complete equation of variation. The last sentence, use that model to predict t when h is 8. Well, that means we're going to take it and recycle it, this model, plug in the part that we know, and solve for the part that we don't know. I'm going to recopy. H equals 36 divided by t to the 2/3. H equals 8 is substituted in for the h. 8 equals 36 divided by t to the 2/3. If you are unsure on how to solve this equation, it might help to make that 8 into an improper fraction. Call it 8 over 1. And then you can cross multiply. If you do that, you will get 8 times t to the 2/3 equals 36. To isolate t, we need to divide by 8 first. We'll divide both sides of the equation by 8. Now you have, when you do the cancellation, you'll have t to the 2/3 equals 36/8. And I'm not going to worry about reducing this or doing anything with that fraction right now. When you want to work on t to the 2/3 to make it just plain t, we will use a reciprocal exponent on both sides of the equation. The reciprocal of 2/3 is 3/2. That leaves on the left-hand side of the equation t equals, and then we can go grab a decimal value for 36/8 raised to the 3/2. Be very careful with your parentheses when you enter this quantity into your calculator. When I do this, I get t is approximately 9.55, and that's rounded to the nearest hundredth. So I put the approximately symbol in there. Let's do a quick check and see if this makes reasonable sense in the confines of the problem. In the beginning, we had a situation where h and t to the 2/3 power are varying inversely. So we restrict ourselves to positive quantities in this course for the variation problems, but as one quantity increases with varies inversely, the other quantity should decrease. So in ours, h increased from 4 to 8 in the problem, and that means that the t value should decrease. T was 27 to start with, and we just found that in the end, t was approximately 9.55. So we've gone the right direction. Things seem reasonable.